We're here today to talk about OpenStack Heat. For those who don't know me yet, I've very recently rejoined Red Hat as part of the OpenStack Tiger team here in APAC. I've previously worked in software engineering, which is quite some time ago. I was a post-sales consultant, a pre-sales consultant, technical project manager, and I'm very excited to be back at Red Hat this year. A little advertising break. We have a newly formed Tiger team, specifically in APAC. Well, team members are Tony, who I believe is in this call as well. He is joining us from China. We have Won-Young from South Korea. We have just brought Peter Jung on board this week in Australia. There is another new hire who is joining us early July here in Singapore to cover the ASEAN region. And we are still looking for someone in Japan. So if you know someone who could be a fit for our Tiger team, it's specifically a pre-sales focused role. Somebody who is fluent in Japanese, someone who is familiar with Linux, virtualization and cloud provisioning tools. We would be glad to speak to him. Let us know. We have a Mojo page for hopefully everything OpenStack related in APAC. I'm posting the URL over here for the internal folks to see. And we're starting an OpenStack bootcamp for the extended team later this month, where we're very excited about. We're looking to build our own internal and external ecosystem for everything OpenStack in APAC. And this is supposed to be well, a platform for connecting all the people and the information together. If we can help, please let us know. Right, this is an introduction to OpenStack Heat. Ravi from India was supposed to be doing this session. I was stepping in for him. Let's see what we have here. So we are talking about Heat. What is it? Why should people use it? How does it fit into the context of configuration management and orchestration tools? What's the architecture? What components are involved? What about templates? What to do with it? And we have two demos. One of them is a quite simple deployment of a stack using Horizon. And we'll also look at autoscaling through the command line. Okay. You guys can hear me still okay? If anything, please let me know. The OpenStack system should be quite familiar to everyone. I think you've seen a couple of great sessions before. There was one on the installer just now. So most people don't need an introduction to our infrastructure as a service cloud operating system. Most people have seen that these are all specific components that are scaling individually. They are all autonomous. They are focusing on compute, on the various storage and networking functionalities, and recently have seen Stilometer as an add-on for everything metering and monitoring. And Heat itself is something that's relatively new and is now part of the core projects since very recently. OpenStack as a framework relies very much on drivers, plugins, and is very much API specific. And everyone who's worked with it, OpenStack, both from a GUI or from a command line perspective, knows that there is many steps involved in provisioning resources. In most cases, people will not be interested in just having an individual server. They will not just be interested in having a specific storage device or an IP address. Complex projects, complex deployments, talk about topologies, about groups of servers, about servers that have storage attached that work in specific network contexts. You've certainly seen that very recently there is even more services coming into the OpenStack world, such as database as a service, load balancer as a service. So all these boxes are even going through significant change. So you've seen the evolution of software-defined networking in the OpenStack world, where there is a couple of things changing. You've seen the various storage options in OpenStack with Glance and Swift, and now even the exciting concept with Ceph coming into place. All these modules are seeing significant change. There is various ways to interact with all of these services, and the APIs are quite complex. So this is where Heat comes in the picture. I've just found out very recently where the name comes from, and they said heat makes clouds rise, and that is apparently the origin of the name for the project Heat. So yes, what's Heat? It's an orchestration engine for OpenStack. Just like what I said now, it's about deploying topologies, deploying group resources as opposed to deploying and configuring individual components manually through either the API, through Commandline tools, or through the Horizon GUI. The idea pretty much is that you treat infrastructure like code. When you look at a whole life cycle of a deployment, when you think of topologies, it's pretty much a platform as a service story as well, where you basically automate everything that a typical administrator would do. Think of a typical life cycle. I go to the Horizon dashboard, I provision a virtual machine. I go to the dashboard, I assign a floating IP to this Nova instance. I go to Swift, I go to Cinder, I provision storage, I create an attachment to the Nova instance. I'm choosing a virtual file system to attach to this instance. Deploying a topology is one thing. Keeping it running, keeping it scaling is another thing. So this means once a topology is up and running, you want to be able to watch how it performs, and you want to be able to scale it up. You want to be able to have high availability of the topology to operate it. Heat was conceived after AWS CloudFormation came up, which is a very similar concept that Amazon came up with. Most people know Amazon just for EC2, which provides virtual compute. Many people know S3, which is the storage engine of AWS. AWS CloudFormation aims to do the same thing, that it provisions topologies, and the template format that we see in AWS CloudFormation was originally used for Heat as well, and it's still there, but it's going to be replaced by a different format, and we will look at this in the coming minutes. Good. So while Heat is looking at the deployment of topologies, it also integrates with the existing configuration management tools like Puppet and Chef, for example. Means there is tons of possibilities out there for people to do provisioning and configuration management. Just because Heat is there, it doesn't mean that Puppet and Chef need to be replaced. They rather be integrated. Looking at the context, this is showing the various options that people use for configuration management. So you see Puppet, you see Juju, you see Heat. You see that if we go from the left, from the right, to configuration management, to orchestration, Heat covers a significant better functionality than Juju does, because Heat is part of the OpenStack project itself. Do we have any questions so far? Okay, this is not the case. Let me continue. So why should we use Heat? Why should we talk to our customers about using Heat? It allows us to do deployments that are fully repeatable. You can version your infrastructure like you do it with code. So you can say, my infrastructure is the application. My application is the infrastructure. I can version the infrastructure. I can put CSS tools in place to archive various versions of the topologies that I'm working with, and I have implicit dependency management for everything that I need to do the deployment. It abstracts all the API details, and we've just talked about this with the various OpenStack components, that it orchestrates the individual provisioning of the components, and there is just one API, just one template to work with, and the user doesn't have to deal with the individual components. The deployments they can be complex, they can even be nested. They're modular, they can be reused, and most of all, there is a simplified management of group resources for it. So the concept in Heat is that we work with stacks. There is a list of resources that can be, and we'll see that in a short while. They can be coming from basically all the various modules that OpenStack offers. In a very simple scenario, we would have a server with a volume and a volume attachment. We will see this in a demo later this hour. These are the resources that OpenStack offers. I'm sorry. So natively, the OpenStack resources are coming from Meter, which is very recently. We have Cinder volumes. We have the various Neutron modules, and of course the Nova resources and from Swift that we can use for the compatibility layer to AWS. We can basically achieve the same thing using the same API as we would if we were talking with Amazon. So, for example, the autoscaling policies, which we will look at in a short while, we can have the same functionality as with EC2, where we have it's called elastic IPs. We can use subnets. We can create S3 buckets using Heat. Good. So to work with Heat, we are defining templates that have parameters. This is basically what we want the template to do. So in the example that we will see later, it's, for example, an instance with a WordPress and a database and a load balancer. For these templates to be active, we will need to have specific resources, such as a Nova instance, a load balancer, a storage volume, and an attachment, and this would be the outputs of the template. In order to use these templates, we will have resources that are identified by references with the various properties that we want from the resource and the attributes that are coming out of the resource. For example, the IP address of our WordPress instance. The templates are defined using JSON. That is, again, the way it was done at the very beginning. It still works today, and the most recent version of our product is still using it. However, everything new and all the new features will be implemented using the new YAML-based templates, which looks a lot cleaner, which allows people to add comments, to add bulk text, and it makes it a lot more readable. Right. Looking at the Heat architecture, you see that at the very top there is various cloud applications that are provisioned by Heat. You see that there is various templates that can be used. There is command line tools, most of all Heat, that utilizes the Heat API that triggers the individual API calls via the Heat engine to the various resources of the OpenStack services. What you see on the right is Heat Watch. This one deals with everything autoscaling and monitoring. At the moment, this is being replaced with an integration to Ceilometer. Very recently, I'm sorry. This has been replaced very recently. One of our demos is still using it, and you'll see it in place. So yes, Heat is the command line tool that we use on the shell. We'll see it in action. We have the Heat API. So that's an OpenStack native REST API that communicates with the Heat engine over RPC. Then we have a query API, which is, like we said, compatible with AWS CloudFormation. And the actual Heat engine, which does all the orchestration and launches the templates, providing the events back to the API consumer. So from an overall lifecycle perspective, it looks like this. We have the stack template at the very beginning, which you will see in a moment. This gets fed into Heat. That talks, for example, with Nova to provision the virtual compute instances. These Nova instances need to have certain guest tools installed that deal with the provisioning of everything that has to happen in the instance itself. And it also triggers REST APIs to Nova Network, to Nova Volume, to Swift, and Ceilometer to do a whole end-to-end orchestration of the stack provisioning. So again, like in our example, think of a template that has a database in it, that has an application middleware in it, that has storage volumes, that has specific network components in it. Those will all be defined in the template. Heat takes care of it and orchestrates the build of the whole topology. Now, we've said that putting something in place is one thing. Making sure that it stays up and that it scales is another thing. So high availability, for example, can be implemented using this. This is still using the JSON coding. So you see that there is a web server restart policy. There is failure alarms that can be put into place. And Heat Watch, which is running, will basically perform all the monitoring. And when a certain condition comes in place, it'll make sure that the system is highly available. The same for autoscaling, which we will cover in one of our demos. You see that there is a web server scaler policy that will be triggered when certain thresholds are being met, where you see a memory alarm. As soon as the memory consumption reaches more than 50%, it'll scale up an additional web server and put it into the load balancer. If you want to launch one of these stacks, there is a couple of possible ways. One of them is, of course, Heat itself has an API that can be triggered. Since recently, there is an integration into Horizon, which means you can upload a template to Horizon. You can reference a URL with a Git to launch the stack there, or you use indeed the command line tools. So there is various options. We can use the command line tool to do a couple of more things. We can validate a stack. We can, of course, create the stack and list it, describe it, list the resources. What's coming in very soon is the possibility to have a stack preview, which will basically simulate the build of a stack and show you what kind of resources this would consume. Good. Before we go into the demo, do we have any questions? And allow me to leave the full screen so I can have a look at the chat window. Okay. Okay. Very good. I'm seeing a question. Will there be a GUI to write these YAMLs? This is also something that you're from a Windows world. Very good. Hi, Siva. Okay, let me go back to the demo. Okay, so we have two demos. They are recorded videos to save time. The first one that I'm going to show you is something that our colleague Thomas Serovic out of Czech Republic has done for us. And that deals indeed with deploying a WordPress instance. So it deploys a virtual machine. It configures a load balancer. And so the idea is to say, as soon as the RAM of the machine hits more than 50%, spin up a new instance and put it into the load balancer. As soon as the load decreases again, get rid of that additional instance and go back to one. And for this one, we're still using JSON templates. Right, I'm switching over to the video. I'll need your help to confirm that you can actually see it. Okay, I need somebody to go on audio and tell me that you can see the video. Wow. Just go to the... Fantastic, see if I can see the video. Okay, let's start this fantastic video. So first of all, this is a JSON config file that was being used. You can basically see that there is all kinds of commands. Hold on, let me just start from the beginning. Yes, so this is the JSON file, the template that's being used. You can see the database details that are being put into the template for the MySQL database to spin up. So the database name, the password, username. You see all the packages that need to be installed on this Nova instance. So in this case, it's MySQL, MySQL Server, HTTPD, WordPress, some Python utilities, and you see the services that need to be spinned up in order for this instance to run. These are some post configuration things for the database. Set up MySQL root, create a user. Yeah, some really nasty SED commands, and finally starting the service. So this is the interesting one. This is and again, from this example, you can see that there is a compatibility with the AWS API. So just to be sure, we're not talking to AWS at all. We're talking with OpenStack resources, but we're using the almost exact same API functionality that we would if we were speaking with AWS itself. So this one basically configures a load balancer on port 80, performs a couple of health checks. So this is the example one, the CloudWatch alarm, where we see there is a memory alarm high. As soon as the threshold passes 50%, then we want the web server scale-up policy to come in place, which basically deals with spinning up a new instance and putting it into context. We should be able to see that here. Yeah. Okay. That's the web server scale-up policy. Good. Now, when we go to the console, and the instances, you should see in Horizon that there is no instance available. Now, the functionality we use, we've just seen this in the slides. Heat list on the command line will give us the list of running stacks, and there is none because it's an empty environment. We've seen there is no instances. So this is the command, and I'm going to pause here. So you can basically see we are interacting with heat via the command line. We say heat create demo. The template file is JSON based, and the parameters that we are feeding into this template is the instant type, is, well, the database credentials that we want to use for this setup, and the key that we are going to use for SSHing into the instance, and at last, the Linux distributions. When you fire out this command, you see that the create is in progress. And from the heat log, there is all kinds of API requests kicking off. Ultimately, you will see that the creation stack is complete. And now when we go back to the Horizon dashboard and refresh the interface, you should see that there is now a web server group with exactly one instance, and you also see an elastic load balancer. They are both in the same network. You see that this is a large instance for the compute node. You see that this is a small instance for the elastic load balancer. And if we scroll, yes, if we scroll to the right, yeah, we can now take the IP address and SSH into this thing that has just been provisioned. So again, this is just what we saw. When we provisioned the stack, we were feeding in the SSH key that we use to provision the stack, and we're using this one to SSH into the Nova instance. Okay, so this is the new machine that was being provisioned. We are becoming super user, and now we're looking at the heat provision log. Like I said before, the Nova instances that we are using have to be provisioned with specific guest tools from Heat in order for the full functionality to work. We are now looking at the log file inside the virtual guest. You see that there is all kinds of commands being issued by Heat. So it's trying to install Apache, it's trying to install MySQL Server, it's installing WordPress, Crony. You see all the commands that this orchestration tool is running. So it's starting the MySQL service. You see, and yeah, you have all the details in the log. It's probably not the most secure way to do it. You see the post configuration of MySQL. You see, yes. So now what happens is we have one WordPress instance in place, and it's behind a load balancer. Of course, this is not a normal setup. If you have load balancer in one instance, doesn't make a lot of sense. So in this case here, we are issuing the stress command, and that should get the load of the machine way after 80% of the memory consumption. For this, we can go back to the log files of Heat Watch itself. And again, this is running on the Heat side. This is not a thing that you will see running on the same machine that we had on just now. This is Heat. This is the engine that is in place to watch over the stack that we have provisioned. And you see that there is a watcher, a periodic watcher, and you see that there is a memory alarm. And you see that the web server policy triggered, and it's now firing off an additional instance. So now when we go back to Horizon and we refresh the dashboard, you can see that indeed now we have 2 WordPress instances, not just one. And they are both connected to the same load balancer. So this is the one on top is the additional one. And you see that the specs are significantly higher than the first one for some reason. So now when we take this IP address and paste it into the browser, opening it up, WordPress, you'll basically see, whoops, doesn't work, not able to connect. And this is basically because Heat isn't even finished with the provisioning yet. It's still taking a moment to do the post configuration and to integrate it into the load balancer. But after a few seconds and after another refresh of the browser window, we are back in business and WordPress is indeed there. Right, we are back at the log file for Heat. And now we are taking off the heavy stress from the machine. That means we are killing this command now. So in a moment, all the stress should be gone, and we expect the scale down policy to come in place. Yeah. Okay, you see here, it says watch demo mem alarm low. So apparently the utilization of the memory has dropped below 50%, which is why the new condition is met, and it triggers the other policy. And it should delete the second instance again. So now if we click refresh, yeah, the instance is gone. Right. Okay. That was the first demo. Can we stop for questions? Let me see if there was some in the chat window. Okay. Okay. Good, all right. So let's see. What have we covered? We've talked about the architecture. We've talked about the components. You've seen the command line tool. You've seen Heat Watch that deals with the monitoring and the auto-scaling. You've seen that, let me, before we go into the second demo, let me just show you the two, because I want to make sure that you understand the two different versions of the template. So this is the one that is the most commonly used version of the templates now. So this is the one in JSON. Most people should be familiar with the syntax. And this is actually the actual auto-scaling itself. So you see this parameter that we feed into the template, which you've just seen when we issued it from the command line. This is the key pair that we use to access the instance. The instant type, the database name. This is what a typical Heat template would look like. And again, it's even using the autoscaling policies. So here's a web server scale down policy. There's cooldown periods, scaling adjustments. Yeah, you see entire commands passed in here, cron tab entries. Very important, the packages, the services that need to be run. To many customers that we work with, everything about spinning up a virtual machine basically ends when a machine is cloned. And in many cases, it's just not finished yet, because there is all kinds of post configurations that need to be done, and you can do all this using Heat. So the properties of the instance, these are the outputs that we spoke about. So basically, I want the template to deploy an auto-scaling WordPress site. Here is what I need. I need compute, storage, network, load balancing. The output that I expect from the template is the URL of my new WordPress site. And to be sure, while we have seen that there were a couple of instances with individual IP addresses configured, those are not the ones I'm actually interested in. I'm actually interested in a scalable website. So my output is the IP address of the Elastic Load Balancer. That means my output, and I will be typing this just into the window here. My output will be something like WordPress, right? Which is an Elastic Load Balancer that will basically distribute the load between 1, 2, and n instances. The new version, and it's called Hot Heat Orchestration Templates. Let's move to the second window. This will very much more look like this. It's a lot cleaner. You don't have all these curly brackets. There is a possibility to add comments, to add bulk text, and it sounded like this is the new way to go with the Heat templates. Okay. I'm just checking back with a chat log before we go to the second demo. Yeah, good comments. Thank you. Right. Okay. We go to the second demo, which basically just gives you an idea. Okay. I'm scrolling up. Oh, okay. I see one question about configuring it in OpenStack and then exporting it to Heat. I've not seen this functionality yet. Yeah, I mean, to be honest, when we see some of the tools that are something that HP offers and IBM offers for their various tools, there is a couple of things that look like Microsoft Visio, where you actually drag and drop things together, and it looks quite flashy. Heat itself, and you've seen this in my slide deck hopefully earlier, Heat is still relatively new, and there is concepts changing. There is new things coming in. So I mean, for example, everything around the AWS compatibility is a great idea, but they've seen that they can't do everything that they want, because I mean, Heat is very OpenStack specific, and OpenStack, of course, is a different environment than AWS. So while the AWS compatibility will still be there, all of the new things that'll come into place, and I understand they have an interesting set of features to look at in the future. They will all be developed just with very heat specific things and keeping the AWS compatibility just as a legacy. So everything around GUI is maybe better to see when we look at the second demo, because it looks a little less command line. However, there is not the full functionality yet. So I'm going to switch to the second video now. Sorry, and this is to I have to start this again. Right. I hope you can see this. This is actually from the OpenStack Summit just a few weeks ago. So like we said, Heat on the command line gives you quite a good control over things, where you can list the stacks, delete them, even very soon be able to preview them. The Horizon integration allows you to do some basic things like provisioning stacks. So when we log into Horizon, you'll see that some of the later implementations have the project panel on the left with orchestration. Yeah, this one. Stacks. And then there is a button. It's called Launch Stack. Here you would be able to select a template. So you could either provide a JIT URL that you have in an internal repository, or you upload a file, and you would even be able to, what I wouldn't recommend, just copy paste the template into the GUI itself. Doesn't make too much sense, I think. So we're going to upload the file, and this is now using the new YAML style syntax. To be sure, what are we actually trying to do? We want to deploy a compute instance. We want to provision a volume, and we want to be able to attach the volume to this instance. So we're selecting the file. Click Next. Then we choose a name for the stack. It's basically similar to the initiation of the command line tool, where we put demo as a tag. Here is something that the team is currently addressing, that for some reason there still needed to be an administration password for certain events. The GUI was still written in a way that it required the password in any event. But I understand that this has been fixed, because it's certainly not the best idea to provide passwords in a redundant way. Right. Once we have all this information and we selected the instant type, we selected the volume size, we selected the image ID and the SSH key. Again, very similar to what we've seen earlier in the command line tool. We're just basically doing the same thing using the Horizon GUI. And we're launching this now. And you'll see, yeah. So maybe this is looking a bit better, also for customer presentations. This is still not a what you see is what you get developer, but at least it presents the topology in a nice way, where you can see, if we go Go a bit back. That you see that there is a compute node, there is a storage, and there is a storage attachment. This is the file that's being used. Again, it's quite similar to the YAML file that I just showed you. It configures an instance. You see the flavor, the key names, the parameters that we are feeding in. You see the volume and the volume attachment, and assigning an IP address. And now when we go back to the Horizon dashboard and look at the instances, yeah, I'm sorry for the resolution, it's not perfect. You see that you actually have an instance provisioned. Now, what we've done is that this template has also attached the volume, and once we log in and become root, you see that there is the VDB with the gigabyte, and you see that it's mounted. Part of the template was also to just create a test file. That was also done. So what we've seen is templates being provisioned by Heat, both with a Commandline tool and with Horizon. We've seen the creation of topologies of group resources, which include compute, storage, network, using templates of various generations, both in JSON and in YAML. Right. If we want to wrap this up, and if you forget everything about this session and just have a few key takeaways, just remember that Heat is orchestration for OpenStack. The idea really is to say, let's treat infrastructure like code. It doesn't stop from just deploying software. Infrastructure, agile deployments. The benefits and the whole idea is to abstract the complexity, because of the various components with their own life cycles, their own changes, with their own versions of various APIs. Let's just take Heat instead. Let's just have Heat orchestrate everything, and let it become like the conductor in an orchestra that makes sure everything is in place. Because the idea is to have a simplified deployment and management of group resources. Right. I think it's just 10 minutes to the clock. Let me go back to the chat window. I'm done with my slides. Do we have questions that we want to talk about? Do we want to open up audio for everyone? Talk about this. Okay, Andrew, I've seen your comment about HP Blade matrix patterns. Yes, I've seen this. I've also seen the orchestration tools that they have, which which is a very different approach. These of course try to integrate with basically everything. So they have plugins for Microsoft, Internet Information Server, Oracle. It's a nice idea. I've seen it in real life, and I've seen well what the difference is between how you position it and how it's been implemented, and how you're able to produce a deployment that is not upgradable, and it's quite interesting. I've seen a comment on using Heat to deploy OpenStack configuration. There is demos that deal specifically with this, so this is certainly while looking at. Okay, there is something on Satellite 6. This one I have to take offline. This is about Red Hat Enterprise Linux. If Satellite 6 is released, Satellite 6 can control and orchestrate all products based on RHEL. And do we have a plan to demand a JSON generator for heat? Well, I mean, if you look at YAML, and YAML is not a markup language. This is where the acronym came to be. The idea is actually that YAML itself is something like a generator. So it might not even be making too much sense to put yet another abstraction layer on top of it, because again, the idea is to say JSON is good. JSON is basically a stripped down version of XML, which makes things simpler. However, there is certain constraints, and there is still too much overhead in JSON itself. So something like YAML makes a lot of more sense. Yeah. So again, I'm not too sure if we should yet have yet another abstraction on top of it. Right. Any more questions? Any more comments, please? I have to say it's quite weird sitting at your desk with nobody talking, not able to see anybody. It's a weird feeling. That I hope this is something for you. Good. All right. If there's no more comments, please remember my propaganda from the beginning of the session. It's we are at the very beginning with OpenStack for us here. With the Tiger team coming into place, looking at supporting the entire region. Reach out to us if you're interested in everything that's OpenStack related in APAC. Subscribe to our Mojo page, reach out to us, and yeah, let's rock. Thank you.